Talk a little bit about horizontal projectiles. It's going to be so fun. A couple things to remember from class. First of all, we figured out in class that vertical and horizontal motion are independent of each other. Whatever happens in the up and down direction is going to be independent of what happens in the horizontal direction. So that was one thing. And then this is also remembering we talked about the bowling ball from the pirate ship, and that relative to somebody on the pirate ship, the bowling ball is just going to fall straight down. So the horizontal motion of the pirate ship and the bowling ball were the same. So relative to the pirate, it's going to fall straight down. So those are just some things to remember. And we're going to start to ask some questions about if you launch something horizontally from a high surface, what's going to be the trajectory, and we can also figure out how far away something goes, which we're going to call the range. So that's how far something's going to go. Let's just start out with an example, and I can show you how some things are going to work here. So let's say that you hike up to the top of a tall building, and you take with you a giant Altoids. There you go. Is it an Altoids or an Altoid? I don't know. And you decide to color in your Altoid or Altoids because you can't see it that well. So there's your giant Altoids. And you're going to do a couple of experiments. The first experiment you're going to do is you're just going to take your Altoid and you're going to drop it straight down. And it happens to be that the building height here is 45 meters tall down to the ground. So there's 45 meters. So first experiment is you're just going to drop it, and you're going to keep track of where is the Altoid or Altoids at some different times after each successive second. So right here at t equals 0, then there's where your Altoid is. Let's get a different color, maybe green will work better. There's where your Altoid is, and then it's going to fall straight down because you're just dropping it. And let's keep track of where it is at t equals 1 second. Well, what we know from our equation x equals 1/2 at squared, and we don't have any initial velocity or initial position, is that after 1 second its position is going to be 5 meters. And then the Altoid's going to fall a little bit more. So here we'll draw the Altoid falling. There it is at 1 second, and then here it is at 2 seconds. T equals 2 seconds. The position is actually going to be 20 meters, plugging back into that formula. And then at t equals 3 seconds, the Altoid is going to hit the ground. T equals 3 seconds, and the position is going to be 45 meters. Or perhaps negative, if you want to make them negative since it's going down. Any way you want to choose it. So that's your first experiment. Then you're going to drag your Altoid back up, and you're going to try a different experiment. This time, you're going to turn gravity off. How do you do that? Okay, so you have a gravity meter right here. So there's your G meter, gravity meter. And then we're going to go 0, and then we're going to make it at 10. And then right now we're going to switch gravity to off. So it's at 0. Here's your gravity meter. So there's your gravity meter. Great. So we're going to switch gravity to off. And then we're going to take this Altoid and we're going to throw it exactly horizontal. And let's say we throw it horizontal with a speed of, I don't know, let's say we throw it at 10 meters per second. Actually, let's change that to 20, because I don't want you to get it confused with gravity being 10. So you're going to throw the Altoid at 10 meters per second. Sorry, 20 meters per second, and you're going to keep track of it at successive times. So we're going to follow the Altoid as it just goes straight across because gravity's turned off. And let's say that this is t equals 1 right here, t equals 1, and we want to find out its position. Well, its position is really easy. 1 second times 20 meters per second, so its position is going to be 20 meters. Keep track of the Altoid. Oh, there it is. Keep track of the Altoid as it goes over here. So here is t equals 2 seconds, and its position is going to be now 40 meters. And there's the Altoid. And then keep track of it over here at t equals 3 seconds, and then the position is going to be now 60 meters. And then there's the Altoid. So obviously not to scale here. This was 60 meters here, and that's 45 meters there, so not to scale. But anyways, it works. Let's bring the Altoid back. And then now we're going to combine those two things together. So this time, let's turn gravity back up to normal. sure if you can see the yellow that well, so perhaps another color is going to be better here. Let's try the purple. So let's turn gravity back up to 10, and now we're going to combine two things together. We're going to still throw the Altoid at 20 meters per second this way, but now we're going to include gravity. So you can see what's going to happen is we're going to combine together what's happening in the vertical direction with what's happening in the horizontal direction, keeping in mind that vertical and horizontal motion are independent of each other. So whatever happens in one direction won't affect what happens in the other direction. No matter how fast I throw this Altoid, doesn't matter what this velocity is, it's still going to take the same amount of time for it to fall. And even if the Altoid is falling, as long as I throw it at 20 meters per second, it's going to have the same position in the x direction going this way. So keeping track at successive seconds, at 1 second, my Altoid will have fallen 5 meters and will have gone 20 meters over here. So there's my Altoid at t equals 1 second. 20 meters in the x direction, and then 5 meters down in the y direction. At 2 seconds, here it is at 2 seconds, so we'll take this over here, we'll take this over here, and there it is at 2 seconds, right? And then at 3 seconds is when it's going to actually hit the ground. Right there. There it is at t equals 3 seconds. And then the path of this thing, it'll really be parabolic, but that's close enough, just like that. So the overall path of a horizontal projectile is going to be the combination of what happened in the vertical direction and then also what happened in the horizontal direction going over like that. And if I want to find the path, then I can just combine them together. This distance right here, how far away did the Altoid land from the building? We can see it's just 60 meters right there. It took 3 seconds to land, and it landed 60 meters away. So let's try another example, and this time we're not going to have the horizontal and the vertical. We're just going to go straight to the combination of them two. So let's see what we can do. This time, let's see, we'll go up to the top of a building. I'm going to make the numbers easy to work out for now. And by easy, I mean that the times are going to be in whole numbers. So we're going to make the building or a cliff or whatever you walked up to 80 meters high. And let's say you haul this giant soccer ball up there. It's a little bit too big. So there's the giant soccer ball, and there's the pattern of the soccer ball. Great. And you're going to throw this soccer ball with an initial speed of, let's call it 30 meters per second, exactly horizontal. And the question is going to be, how far away does it land? That's also known as the range. How far away something lands is also known as the range. How do we figure this out? Well, we're going to actually do two different physics problems here. We have something that's happening in the vertical direction, and we have something that's happening in the horizontal direction, and we're going to keep them independent of each other. The link between them is going to be time. So time is going to be the same in the vertical and the horizontal direction. What's happening in the vertical direction? Well, if we just ignore the horizontal direction, you just have a ball that's falling 80 meters, right? So let's do the vertical and horizontal, and then we'll combine them. But the vertical direction, I can just write my good old x equals 1/2 at squared equation, plus the other stuff that's not really important right now. From the vertical direction, I know the distance right here, the vertical distance. Sometimes, by the way, people write this as y equals 1/2 at squared plus that. Since we're talking in the vertical direction, sometimes people like to use y. So it doesn't really matter what we call it. But to plug into this equation, I know that the ball is going to go 80 meters in the vertical direction, 1/2 gravity, 10 meters per second times time squared. If I want to, I could call gravity negative, in which case my 80 meters would also be negative because it's falling down. It starts up and it falls down, so this 80 meters would be in the down direction. So it doesn't matter. If I solve this, then I'll find out that t equals 4 seconds. So it's going to take the soccer ball 4 seconds to hit the ground, independent of this initial velocity. If this initial velocity is 30, it takes 4 seconds to hit the ground. If this initial velocity is 100 or 1,000 or 1,000,000 or 0, it still takes 4 seconds to hit the ground because the horizontal motion and vertical motion are independent. Now getting back to the horizontal direction, if I want to find out how far it went in the horizontal direction, I can just use distance equals speed times time, since I don't have any acceleration in the horizontal direction. To make sure that this is really, really clear, there's no acceleration happening because gravity does not act in the horizontal direction. So it's just distance equals speed times time, or position is velocity times time. I know what the velocity is. The velocity is 30 meters per second, and I'm looking for how far it goes, and I already know the time. The time is 4 seconds. So I can say x, how far did it go, equals 30 meters per second times 4 seconds. That's 120 meters, which is pretty far for a soccer ball, but you know, this is also throwing a soccer ball at 60, 70 miles an hour. So the soccer ball is going to go through the air like this, and it's going to end up at 120 meters away from the edge of the building. That's 120 meters right there. So I want to point out a couple of things that you should watch out for in doing these problems. That's basically it. Well, let me point out the things to look for and then the things to watch out for. So there's three sort of factors here. There's how high is the building or cliff. There's how fast was your initial velocity, and then there's how far did it go. And then it's all linked together by the time as well. So the time is the link. If you're given any two of these, you can find out the third. If I'm given these two to start with, I can find out this one just by the method that I showed you right there. If I'm given these two, I can figure out this one, and vice versa. Or if I'm given these two, then I can figure out this one as well. So you can do all these problems. Some things to look out for are that sometimes it gets a little confusing for what that initial velocity means. Because if you're looking at your equation, y equals 1/2 at squared plus v0t plus x0, this is all for the vertical direction. You might think, okay, I'm trying to figure some things out in the vertical direction. Oh, look, initial velocity. I should take this initial velocity and put it in there. Don't do that. This initial velocity is only in the horizontal direction, right? It's just in the horizontal direction, so you don't need to do that. So that's one thing to watch out for. Another thing to watch out for is over here in the horizontal direction, you might be tempted to use 1/2 at squared plus v0t plus x0 and plug in gravity or something there because you know gravity's going on. So don't do that because gravity does not affect the horizontal direction. In fact, the equation in the horizontal direction is valid. This is an equation. It's the right equation with a equals 0. So you just get x equals v0t. Or a better way to write it is just x equals v times t. Right? This v0 is your velocity, and that's the horizontal velocity. So that's how to solve horizontal velocity problems, horizontal projectile problems. Hopefully this was helpful for you all, and now you have some worksheet problems to do.